All right. Hey, welcome to the AI short course. Starting with our first presentation, a brief history. That should be in quotes. Not so brief. The video itself will be a little while, but the content is a brief look at the recent past of AI and the way that term is used and why we're in the middle of something kind of crazy. Uh, Also known as I blinked in 2023, what the hell just happened? So, let's get into it. I want to lead off with this idea. Take this description. A stylish woman walks down a Tokyo street filled with warm, glowing neon and animated city signage. She wears a black leather jacket, a long red dress, and black boots, and carries a black purse. She wears sunglasses and red lipstick. She walks confidently and casually. The street is damp and reflective, creating a mirror effect of the colorful lights. Many pedestrians walk about. So, this is an order of words, an order of symbols presented to you, and in your mind, they might be sparking a little bit of imagination. You might be starting to picture this thing. You might be sketching it mentally or relating it to other things, right? If perhaps you're aphantasic or something. So, this is a description written in words that can evoke a lot of concepts, right? This is the Sora model released by OpenAI about 2 weeks ago. Not released, it's announced by OpenAI about 2 weeks ago. This is a completely AI generated piece of visual content based on that exact prompt I just gave you. The level of detail and coherence between frames and the quality of the reflections, the everything here is a little bit astonishing. I mean, look at what we got. The tufts of hair on this, like the reflection in the glasses. It's pretty wild. You know, we may have seen a bit of Will Smith eating spaghetti. I'm not going to put that in this video, but this is where we're getting to, right? But here, let me throw this forward. Okay, this is a text prompt resulting in HD video. That is the information transformation that has occurred with this AI model. It's going to play again. I want that to show up. Okay, so Sora is a text-to-video model by OpenAI. This image did not exist before Sora generated it. About a week later, someone dropped Emo, EMO, which takes audio files and a single image to create this.
Did a full 180, crazy, thinking about the way I was. Did the heartbreak change me? Maybe, but look at where I ended up. I'm all good already, so moved on, it's scary. I'm not where you left me at all. So
She does not exist. This person does not exist, and in the space of 2 weeks went from being generated in a video to being brought to song with Dua Lipa.
did a full one.
There we go. Within 2 weeks. This is just to paint where we're at. Our focus today is not going to be on video transformers, audio transformers, all these different kinds of models that are out there now. We are going to focus on language as the core question, because that's where the real immediate leaps have been happening. But just remember, all information is information. So visual patterns, language, everything, these strides are all starting to swirl together, as you can see. Text to video to image to audio to image audio. So, the field of AI is experiencing an explosive renaissance. And I think if you're seeing this, you're probably already clued in to some extent. This rapid expansion and evolution of technology centered on AI But I want to acknowledge, and part of what we're doing here today is acknowledging that like the term AI has been used for a long time, and it's always been sort of like hyped up in different ways, and it's kind of been a little flat. Not every time, but like it's a little bit. What's really the big deal in terms of when you hear people going on and on about AI? And like I said in the title slide, if you blinked, you might have missed it. Or if you weren't initiated, you might have missed it. What is actually changing here? So my goal today is to examine this brief history of AI in recent years, leading up to a really strong tipping point, leading up to the burst of activity we've begun to see, and this strong phase transition. So, yeah, let's explore. First, a little bit of terminology. It's pretty important to get this stuff, at least operational for the purposes of this conversation. So, this presentation, I'm going to call AI as I see it. There are a lot of definitions for the way that you can use the concept of AI, but I tend to find it as any system along a spectrum, but any system that involves some amount of the system itself making informed decisions that go beyond just responding to the user's simple inputs, right? Now, in that case, you might call a calculator AI. Yeah, a little. I would, this is why I talk about it as a spectrum, right? How much intelligence is in the system. There's some flavors to this. Symbolic AI is like the classic kind of rule-based systems for deciding how AI in video games functions and making state-based decisions about, okay, if I am in this scenario, I will do this thing. If I'm in this scenario, I will do this thing. Machine learning is the more broad term for the types of training AI systems using data and capturing things in mathematics and statistics and other kinds of algorithms that help with things like pattern recognition, inference, prediction, these kinds of things. Neural networks are a specific flavor of all this, and key to what we're talking about here, that are inspired by human neural processing, right? Neurons, you got a bunch of them. They come in huge groups and they do a lot of processing together at once in parallel, right? So that's kind of the core concept. The neuron itself is a fairly simple unit. Shh, don't tell any biological psych people that I said that, but that's because that's not true. It is a complex, very complex cell. But at the level of information transition, a neuron is a relatively straightforward unit. And that's what the neural networks are mirroring. They use simple units, but in huge numbers. So that's kind of AI in general. The use of tools to inject intelligent decision-making into a broader tool. So generative AI is the idea of when AI systems are getting complex enough that it's not really just simple pattern matching or simple prediction anymore. It's capturing complex enough patterns from its system that it's engaged in that it can create new things. It can apply super complex abstract patterns to new scenarios and generate new things. That's a new realm. This is where generative AI has only recently started to kick off. And the reason is it requires sufficient scale and complexity to be able to capture those, abstract nuances and generate new things. Finally, conversational AI is any AI system that uses the concept of a conversation as the primary form of natural language interface, right? So to get there, it takes a lot of work. You gotta fine tune these models to get them to do this, but it is another turning point. You'll see as we go. So here's the phases of this presentation. 2010s is like the AI is kind of everywhere already. It's just simpler and more piecemeal and maybe limited in scope, right? 2020 to 2022 is when the tipping point starts to tip. Things start to pick up with art and text comprehension, to art generation, text comprehension, all of these things starting to catch the attention of the public eye. And then finally in 2023, we have a collision of two major events. A flagship model gets released that is smart enough to do things like debug its own code, and a research model gets leaked to the public, and then the entire world gets their hands on it immediately. Woo! So let's start with the 2010s. So in the 2010s, and before, but like I'm just kind of focusing on an arbitrary cutoff of like a decade leading up to where we're at. AI is everywhere, right? I think we kind of simultaneously got used to the concept of AI being used in almost every product that you come about, but also this has an effect of diluting its meaning a bit. So things like smartphone assistants, recommendation systems, all these things. We're going to go through each of these, so I won't list them all. Let's look at some of these, right? The question at hand is, what is this? What kind of task is it solving? And what's the AI part doing? So, smartphone assistants. Siri setting your reminders for you, right? What is the AI involved here? And we're not going to get granular. I'm just going to sort of describe it. It's converting your voice audio patterns into meaningful text, which then can be parsed for actionable commands that the system was trained for. Now, it can train on your own data. It listens to your voice more often. It gets better at understanding your voice. It gets better at understanding some of your commands, that kind of stuff. But very basic, right? You never had a good conversation with Siri, right? Recommendation systems. So like Netflix, what's going on here? When Netflix is suggesting you new shows, it's doing this with an AI algorithm, right? It's finding the nearest neighbors to your current show based on some math model of its relationships to all other shows and your tastes. It does all this big high dimensional math, and it comes back with, here's the stuff that's closest to both the shape of this show and the shape of your tastes, and here, give it a shot, right? Now, we know that's often not right. It will suggest all kinds of random crap to us that we don't like, but by and large, it's suggesting things that are at least in range, you know? Customer service chatbots. These are dumb little chatbots that exist to essentially head off the pass for customer service in larger corporate entities, right? So a bank's chatbot might help you with account inquiries so a person doesn't have to get involved if it's simple enough, right? So how does it work? It's mimicking natural language with some pre-canned responses like, hi, how can I help you today? But it also is providing aid based on things like sentiment analysis. It can quickly assess if the language you're using is like positive, neutral, or really negative, and it might take a different tack either way. But it's really just working with pre-canned things kind of like Siri would, right? It's saying, oh, I'm looking for this catchword. Oh, I can link you to this part of our documentation, or here's the site to sign up for that, or whatever. Again, not clever, right? It's more of an applied tool that aids the business, right? Social media algorithms, Facebook's news feed personalization, right? So this is their whole thing. This is their whole business model, right? They arrange your feed based on what you have historically found the most engaging, which oftentimes is stuff that makes you mad, because all they want you to do is spend as much time as possible in the app. That's how they can advertise to you. That's how they can get you to buy things. That's how they can get you to sign up for their special thing, right? The more time you spend, the more valuable you are. Ooh, are you the product? Autonomous vehicles. Super important to our near future. Tesla has the autopilot function, right? And this one's hard because it has to process a wide variety of inputs. So like visual, a lot of visual. It's using LiDAR, so it's a little bit better than human vision, but it's using both of those things. And it's also, I'm sure it's parsing audio. It's doing all kinds of sensory things that it's possible to make these really critical decisions about how do you interact with the car? When should I brake? When should I accelerate? When should I steer? and by how much, and all these things. And it has to do them in a way that is relatively safe. We have already, in 2018, seen our first death at the hands of an automated vehicle. That's fun. Let's keep it going. We got a lot to get through. Email filtering. Now, this doesn't even sound like AI in any real way, right? But it's still a kind of categorization task, right? It takes a certain kind of knowledge and understanding to group emails into relevant groups, categories, right? So it finds the patterns in the content of emails that you're receiving and can organize it into useful subfolders. The most obvious of which is like your spam filter, right? Your spam filter is picking up on broken language and imitation of legit sources and stuff to deliver you trash, and thankfully it's pretty easy for Google to catch most of that stuff, right? Healthcare and diagnostics, so this is having a diagnostic system that helps offer treatment options to doctors, right? So they would use this as a tool. It's not doing their full job, it's just a quick reference mechanism. And what it does is it presents a series of questions for them that are designed to maximally rule out possible diagnoses, because it's been trained across a huge set of data to determine what are the most useful questions to ask first, right? You can see how that is baking in human intelligence from human flavored intelligence from a data approach, right? Financial trading bots are a similar thing. It's predicting. These things have been trained to look at patterns in numbers, obviously the market data, how they move up and down, and try and predict when things are going to change favorably or unfavorably, and then make high frequency trades, like some of them thousands of times per second, which might be one of the problems with our current market, but who knows. So yeah. Oh, video games, we talked a little bit about before. The NPC behavior in Skyrim, for example, right? The AI is picking specific actions for this entity to take based on the properties of other entities in the environment. For example, if it sees you and you are tagged as its enemy, then it will orient towards you, move toward you, and then attack you. That's a series of decisions that it has to make that are based on the behavior that the programmers wanted it to exhibit in the game world. And again, this is very, very symbolic, very like symbol level, like if then reasoning, not the more complex stuff that we're looking at here. And finally, autocomplete. And this one I save for the last because it's very relevant. We'll see that going forward. Your phone keyboard autocomplete, right? Or predictive text is another way to put it. What is the next word that is most useful for you in the setting that you're in? And so these things have evolved a lot over time, but they break down into the very simple act of, based on, the general statistical properties of language as a thing, as well as your own specific like typing data that you've given it over the years, whatever, it tries to make predictions that will be useful to you for, I can just complete this one. Right? That has a lot to do with modern AI. It's just increasingly robust versions of this. So, to recap, 2010s. We've got this smorgasbord of ways that AI is incorporated into like all kinds of live products and services in your life, right? They're all various ways that we've worked intelligent decision making into our systems, and some are driven by like actual data from the real world. And others are more like top-down decisions made by the programmers, but that's a key feature. They are balancing those two, and they're pretty narrowly scoped, right? A chatbot is only going to handle account inquiries. You can't ask it what the weather's like. A personal assistant can only really parse some of the natural language you give it. Often, Alexa so often will be like, I don't understand, or I'm sorry, I can't help with that, because it has no fallback for when you ask it how many basketballs will fit inside the circumference of the moon or whatever. So you could try that. I haven't tried that with Alexa, actually. It might try to answer it. So And then financial trading bots can only see certain stats and make predictions about numerical trends in market data. It can't help you figure out. It can't even help you figure out like what to buy at the grocery store. It's not trained on that kind of data. It is trained only on a specific set of information that was given toward its specific purpose, very narrow in scope. Things start to change in 2020. Also, this is a little bit of a history of AI. I just threw this up there because it's interesting. I'm not going to talk about all these, but if you're ever curious about some of these deeper histories, check into it. Okay. Prepare for occasional cuts. All right, so this is the 2010s. Let's keep it going. 2020 to 2022, this is when we reach a tipping point and start to teeter. 2020s is really a lot about large language models. That is the core thing that we're dealing with these days, right? And one specific innovation that comes along is in how language models can be structured. The transformer model architecture is the key thing here. We'll talk about it in a second. This is the spark that allows these models to start scaling, and then the company that we're focused on here, seeing where they take that scaling, right? The OpenAI. Then, once they have something powerful, they pivot into this conversational AI space in the form of this natural language interface, which that's the real rocket fuel here in this phase. So let's talk about all these things. The transformer model architecture is born. Now, don't look at this thing on the right and panic about memorizing it. That's not the point. It's more about showing that there is a flow of information that goes into these large language models. They are processed in very discrete steps, lots of layers of neural networks and stuff. But end of the day, it's just a program. It's a large one, but it's just a program. This shows the flow of that. So to be clear, thoroughly defining neural networks is beyond the scope of what we're doing here, right? But it's useful to know that neural network architectures have been evolving continuously and not in a straight line, right? We had the most basic ones, which are feed-forward networks that just kind of send information along. Recurrent neural networks are ones that can sort of reactivate themselves. Long-term, short-term ones have different shapes. Convolutional neural networks can do things like vision because it's doing like linear algebra stuff like on a screen. That not all super material here. The main point is that the transformer model comes in and offers a sort of a turning point. And there are three features of the transformer model that are important to have a mental set for. It's parallel in design, meaning that the algorithm has gotten to a place where it has exponentially shortened the training times of these models. So whenever you're training any model, any AI model, language models included, you're training on data, right? A lot of data. And the more data, the better is usually the idea. You want to get a really broad coverage of as much kinds of stimulus that you can get for these systems. And data that might have taken centuries before the transformer model now takes weeks to train, right? That's a huge condensation of time. So now these things have incredible reach in terms of what's feasible to do. They're also scalable. So the model works efficiently across large-scale distributed networks, as well as distributed processing like on a graphics card or whatever, right? And this scalability is what allows the compute to be scaled up, right? So not only can you train them a lot harder, you can make them a lot bigger, right? Those two are huge. Now, the magic sparkle here is the attention mechanism. So transformers have what is called an attention mechanism. It's the idea that if we're dealing with language, right, the idea is that the meaning of words change based on their context, right? If you said, let's roll back a little bit to like 90s slang, or maybe that's early 2000s, bro, that's so sick, is very different than, bro, I'm sick, right? Those are two different concepts that are wildly off, but they look very similar, right? In terms of just flat language. So the idea that words are modified by the context in which they are used, by the other words they move together with, all the words in a system, in a sentence, in a paper, modify each other, right? If the same word shows up repeatedly in like a journal article, an academic journal article, that word has a different meaning in the context of a journal article than it might have in other places. In fact, just the term AI that I've provided during this presentation, it might take on a different flavor if you transported this to the 1970s and we're talking about, well, what does AI mean today? It would be different, right? So this is key, I think. This is a really key piece of the puzzle because it's making it so that the words are not just presented as objective tokens of knowledge, but they are presented as tokens of knowledge that have relationships to all other tokens of knowledge. It's a little bit hard to immediately grasp this, but I think that's the key insight, and that's what everybody's banking on over at OpenAI. So, 2017, OpenAI enters the fold to build GPT. I have it on here, Generative Pre-trained Transformer, right? Meaning it is a generative model because it's creating text and it's using it to try and apply new concepts, and it's pre-trained, so they trained it once and then you start using it, and it's a transformer. So it's this kind of AI model. OpenAI gets in here and they are coming at it from this kind of weird hybrid of a research foundation, good of humanity approach, and this like capped venture capital thing that continuously keeps getting eaten more and more by Microsoft. Who knows what's going on, man? Don't mess with corpo politics. But they are getting sued. So, but what were they doing? Why are they worth suing? What's going on here? So they're playing off the strengths of this transformer model. They are saying these models can now process a lot of data. We can get a lot of data. They can rent a lot of cloud computing resources to both train and deploy these tools. And here's the trick, the magic sparkle, is where's this attention mechanism going to take these things, right? Where are we going to get if we allow these things to scale up as much as possible? What's that going to do? So that's their main innovation. They're thinking that the complex capabilities enabled by this attention mechanism are going to emerge and alchemize as the scale of the model goes up. So that's what this series of models is, the GPT series. Just a quick look. This is sort of people are used to ChatGPT by now, probably, but this is more the classic back-end version of this, where it's just like, there is a model in here. You can give it inputs. You can kind of adjust its pattern, or not patterns, its parameters, right? You can change things about it. We don't need to focus on this, but the point is just to show you that, like, this is what GPT looks like up until ChatGPT emerges. It's a tool for developers to explore what's possible using language models. Interesting. So let's get into the timeline here. What I'm going to sketch here is the sizes of the models in terms of the number of neurons they have, and some of the features, and like a quick sketch of an example. So Transformers come out in 2017. This is like a new model architecture is released and published, and people start playing with it. 2018, OpenAI picks it up, and they say, okay, so they start with GPT-1. It is, I put 0.1 because it's billions, 117 million neurons, right? So 0.1 billion neurons. It's able to exhibit some very rudimentary things about language. I believe, I wasn't there for this, I wasn't paying attention at this point, but I believe this is where they're starting to see, oh, this is kind of interesting. It does so well with so little. Basic comprehension of text patterns. It can do some simple question answering based on like the knowledge encoded in the data that it received in training. And it can give you some like very overly literal translations between languages. Not great, but non-zero, right? And an example is it can complete a single sentence pretty easily, right? The quick brown fox gives way to jumps over the lazy dog, that sentence that contains every English letter. That's GPT-1. GPT-2 is 1.5 billion neurons. Okay, we have increased in size. This one starts exhibiting improved comprehension and text generation. So it has better handling of what we're talking about in the context of a perhaps conversation, or in the context of a larger, like, here's a scenario, please complete blank. And it can generate coherent short stories and articles. This one, I mean, this is back as far as GPT-2, but this is the whole like unicorn science article, right? In a shocking finding, scientists discover a herd of unicorns, and you let the model pick it up from there, living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. This is the model picking up a trend, picking up a pattern, and producing pretty damn plausible text. It doesn't match with reality. We all know pragmatically unicorns ain't a thing. And it hasn't really been asked to do this in a way that is like, hey, be creative. It's just sort of riffing. It's not doing it very smartly, but it's doing it in a way that seems decent, right? That's GPT-2. GPT-3. Now, this is where we're getting to a place where there is some notable stuff starts to reach the public a little bit. This is in 2020. GPT-3 is 175 billion neurons, and it starts to exhibit a deep understanding of context and language nuance. It's capable of writing not just like things that look like essays, but things that sort of satisfy essay constraints. It's able to solve more complex problems and have more human-like conversations. It's generating code, and it can work on tasks with less hand-holdiness, right? So, for example, say it can illustrate multi-step reasoning and justifications. You say, to mitigate traffic congestion in urban areas, a multifaceted approach is necessary. Firstly, implement a dynamic pricing model for toll roads, adjusting costs based on blah, 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 blah. I'm not going to do the whole thing. The idea is it's pulling information from various places from its training. It's walking through a line of reasoning. It may not be perfect, but it's still something we haven't seen up until this point. GPT-3 is where things start to get a little more public announce-y. You start to see it pop up in the news. On the right side here, we have college student used GPT-3 to write fake blog post and ended up at the top of Hacker News. This student noticed how good this thing was and started using it to generate, garbage blog posts that looked great and satisfied the basic constraints of getting attention and clicks. And then Hacker News picked up their junk stories. So, kind of funny. But it's also kind of passing the public Turing test there. Ugh. We won't talk about the Turing test. That's, you know what? Quick aside. Turing test it's not an actual test, right? It's more of a basic checkbox, kind of like the Bechdel test in movies for female characters. It's the basic checkbox that if the thing can fool you into you thinking it's human, then it's passing the Turing test. But the fact is that cat's been out of the bag for decades, right? Set things up right, a lot of systems can fool you into thinking that they're human. Play any game online these days that has a bunch of bots instead of humans for your first 20 games, and you probably wouldn't be able to tell the difference, right? Okay, that's a goofy aside. Another fun one is AI Dungeon. So this was you think about RPGs and tabletop games and narrative games, right? And they all have these systems and rules, but what if you could just skip the rules and have a conversation with a dedicated narrator? That's what AI Dungeon's about. You can still go there. It's still kind of fun to mess around in there. But this is an emergent property that was not really available up to this point. It ain't perfect at keeping track of what you're doing and what you're talking about, but it gives you compelling things to riff on in this back and forth, an interface, you might say. And that is sort of where we, again, re-angle the ship. So, GPT-3 was 2020. GPT 3.5, also known as ChatGPT, is 2022. It's the same size, it's the same base model, it's just been trained in a lot of ways. So up to this point, we can see OpenAI strategy playing out, right? They show results, they scale up, they see what happens. They show results, they scale up, they see what happens. Now they feel like they have something, right? They see these things coming and being used in naturalistic conversational ways. They see it being used in, compelling ways that are reaching, penetrating the real world journalism in ways that are dubious but extant, right? So now they say, okay, we have to reorient this around a usable human interface. And what does that look like? That's the chat part of ChatGPT. So there are two big jumps up from GPT-3 for GPT-3.5. It is streamlined to be a lot faster and cheaper. This is why they're giving it away for free. This is their advertising revenue budget, right? They are saying, hey, anyone who wants to use this tool, come on and chat with the thing, and you can get as much text as you like because it's pretty cheap. They also fine-tuned it to engage in conversation. So, for example, if you input "hey" in the older models, instead of just trying to complete the language pattern, like if I put "hey," it might then complete it with Daniel, just saying hi again and wondering if you had a chance, like some corporate email that it figured, okay, that's plausible, right? This one was trained instead to treat this as its own turn in conversation. There's a lot more structure to the way that it has behaved, the way that it parses its input text, because things are being broken up into conversation turns now. So instead of "hey" becoming a completion, "hey" now becomes, that's the end of the user's input, and now it's my turn to talk, which is now, "Hi there, how can I help you today?" You might recognize this as an interaction loop. This is a human interface now, suddenly. I can't overstate how important this is, right? This is a usability major change in the tool. Instead of being a little back end that you type little, careful prompts in and see what the single result was, this is a iterative, organically evolving conversation that picks up more details over time, back and forth between the user and the system. You are generating a more and more compelling conversation as you go. You can iterate, and that's huge. This puts us in the realm of HCI, human computer interaction. This is an interface. This is an interaction loop. This is where things take off. So to recap this, 2020 to 2022, we watched this one company, OpenAI, pursue this logical trajectory of scaling up the transformer model to see what happens as complexity increases, right? The models evolve steadily over this time, from like, haha, neat, to what the hell did it just do? So, and finally, once they feel they've got something marketable, they pivot it into a natural language interface tool. And that's where it starts to take off. And the evidence that it takes off is it took ChatGPT 5 days to reach 1 million users. That's pretty fast on the balance. So, okay. That's 2020 to 2022. Let's get to 2023. I put this into two kind of simultaneous events. The spaceship has landed on the front lawn, and the doors have been blown off the barn. We'll address them each in turn. Two major events. The spaceship landing on the lawn is OpenAI launching their next iteration of GPT-4. The doors have been blown off the barn is Meta's research-friendly llama models escape into the wild, both in March of 2023. This is why the past year has been a little crazy. So, let's talk about the spaceship on the front lawn. OpenAI releasing GPT-4. What's the deal? Well, GPT-4 2023, the exact numbers aren't known. They won't share them exactly, but it is thought by people, by developers in the field and who make these educated guesses, that it's about 2 trillion neurons, 2,000 billion neurons. That's a lot of neurons. And for comparison, I think this is a useful thing to do when you're thinking about complexity. This is similar to the difference in number of neurons in the nervous systems between dogs and humans. That's a lot. That's a lot. So this is a huge scale up in size, and they've got this massive training data set that was almost certainly stolen from every single corner of the internet. Some legitimately, some less legitimately, unclear on all of it. But it's been trained on a lot of information. I mean, think, even just it eating all of Wikipedia 10 times over is a lot of information. So the key thing is that there's a lot of room in a model this size to absorb a lot of complex, nuanced abstractions from natural language as a thing, and that these capabilities can emerge and flourish in a model of this scale. So this is Greg Brockman. Now I forgot to set the time on this one. I'm going to pause real quick. Okay, got there. So this is a short video from is he the lead engineer? Like, who cares? Somebody at OpenAI who is part of the development team, and he's demonstrating some ideas here. Right here, leading up to this moment in the video, is he's having it play word games with, like, hey, summarize this GPT-4 release article, and only do it with the letter G at the start of every word, which is, okay, honestly, that's impressive because it's following these rules. That's something that GPT-3.5 couldn't do, and it demonstrates it in the start. It just ignores the concept of trying to use the same letter, right? And this one, it doesn't matter what letter you give it, it works on it. It ain't perfect, but GPT-4 quintessentially quickens quality quantifications, quelling questionable quandaries. Oh, Lord. But again, that is a very complicated level of abstraction. Let's let him talk about combining two article summarizations.
So, I've shown you summarizing an existing article. I want to show you how you can flexibly combine ideas between different articles. So I'm going to take this article that was on Hacker News yesterday, copy paste it into the same conversation so it has all the context of what we were just doing. I'm going to say, find one common theme between this article and the GPT-4 blog. So this is an article about Pinecone, which is a Python web app development framework, and it's making the technology more accessible, user-friendly. If you don't think that was insightful enough, you can always give some feedback and say, that was not insightful.
He just asks for more insight.
Enough, please. No, I'll just leave it there. Leave it up to the model to decide. So bridging the gap between powerful technologies and practical applications. Seems not bad. And of course, you can ask for any other kind of task you want using its flexible language understanding and synthesis. You can ask for something like, now turn the GPT-4 blog post into a rhyming poem.
And there it goes, composing a poem.
Picked up on OpenAI evals, open source for all, helping to guide answering the call. Which, by the way, if you'd like to contribute to this model, please give us evals. We have an open source evaluation framework that will help us guide and all of our users understand what the model's capable of and to take it to the next level.
There's a longer version of this video. We don't need to get into, but that's a demonstration right from the devs showing a very quick, compare these two articles and summarize a difference between them and then turn that into a rhyming poem. That's a lot of layers of complicated transformation of information. And that's what we're seeing with GPT-4.
Honestly, it's kind of hard for me to believe that this...
Restarting the video. Okay. So, the big slide, don't worry, we'll get through it. What is actually different about GPT-4? And that's sort of the big question of the day. Why is it such a huge leap? What are we talking about here? And I guess a caveat is you're going to have to use it. to understand that. That is a sort of a primary thing here, is that it's really hard to illuminate these things directly. But as you use it for things that you kind of understand, you start to see what it is capable of, what it's not capable of, but more what it is capable of. So that's a quick aside. I think it's worth noting. But this is sort of in response to, oh, at the end of the day, it's just a text generator, right? And I have a cheeky response, which is, well, when you're typing code or writing a paper, what are you doing exactly? Are you just producing one token of text at a time? Interesting. Tell me more about that. But, cheeky. Let's get to the more, well, concrete is perhaps the wrong term, but what are these capabilities, right? What are the things that are emerging at the level of GPT-4 that didn't exist before it? The level of linguistic finesse, these higher order features of text like sentiment and emotion. I didn't drop it in here, but like style, it can emulate your style pretty well. It can emulate your accent if you write in a particular way, like like the KFC Colonel Sanders or a Cockney British gentleman or whatever, right? Information synthesis, so it can answer complex questions drawing on its encoded knowledge or knowledge you just paste right in from multiple disparate sources to synthesize into something useful and perhaps, as we discussed, insightful in the Brockman video. Its creativity and coherence is like it can form narrative threads that are maintained and elaborated in plausible and intriguing and sometimes satisfying ways. It's really annoying when it writes a better story than I can for like a D&D campaign or something. And complex problem solving. So it's able to take complex problems that involve many steps, break those steps down, and again, novel problems, things that it has not seen before. You combining a set of unique parameters and saying, hey, try to solve this, and it will break it down as best it knows how. That's interesting, right? And it can use principles and ideas and patterns and theories and anything from its training data or from information you paste into its context window, whatever. It's able to do a lot of complex things in ways that has never been seen, right? And then programming capabilities. GPT-3 gives decent code snippets, and it can help you like understand some things about code, but GPT-4 can deliver a custom fit solution for implementing specific design patterns and constraints that you provided. And it can like break that down into its own complex problem solving, and it can explain everything to you. It can document the code. It can check for errors, right? It can do a lot of stuff. I borrowed a lot of these from this article from Search Engine Journal. It's just a nice quick recap of some of the things that they thought were most impressive, and I jumped on board with it. Also, don't forget that the model just knows a lot too. It ate the entire internet. It, all of Wikipedia, probably several times. Academic journals, code bases from GitHub, Stack Overflow articles, niche hobby forums, every New York Times article. They were suing. A lot of people are suing right now with varying degrees of like legit. And like every Reddit thread that ever like actually solved the problem that humans needed solved as opposed to the rest of the internet, right? It still 100% produces errors. It will produce errors some of the time, and that's why you can't just blindly trust them. But if you start using them in domains that you're familiar with, you're going to start to see they might not make as many errors as you have been warned against, which is kind of wild. So let's look at a few examples. I'm going to touch lightly on them. So linguistic finesse, right? Again, this is from the article. This is the prompt says like adopt a bunch of different accents and then carry on an interview conversation, right? So you are a dialect expert having a conversation, and then it's weird that they asked it to have a conversation with itself, whatever. But the dialect expert is like, today I want to test your skills in different dialects, blah, blah, blah. And it jumps into Cockney, cor blimey, blah, blah, blah. It jumps into South American. Well, I do declare, oh wait, Southern American. That makes way more sense. I do declare hot on a stolen tamale out there. Australian, crikey, mate. So yeah, it's relying on a lot of stereotypes, right? Crikey, mate. But it is adopting these styles. Go beyond crikey, mate, and it fair ding again, too much. But it's capable of adopting those styles on a dime, right? Like it turns itself and doesn't even ask for more input or anything. It just generates all this text in a coherent faux interview, just like the person asked. Information synthesis. So this is the prompt is about, let's talk about the decline in bee populations and the impact on global agriculture. Includes sources, stats, potential solutions, etc. And it's saying write an article, right? Now, would you trust this article outright? No, this would be a draft, but it can help you sketch this immediately. It can take disparate information. It can start to frame some of the main questions you have. It can start to compile that down into like, I'm going to state the problem and pose some basics. Now, are the stats that it's providing real? Good question. Look that up. Look up Potts et al. 2016, right? We don't trust them implicitly, but we do start to see they can frame things in 1,000 unique, powerful ways that save you time, honestly. Creativity and coherence. This one they asked to tell a short story about a detective solving a mysterious case involving supernatural elements. The story should have well-developed characters, an engaging plot, and coherent narrative. And, I haven't spent a lot of time with this particular narrative, but it touches on a lot of things. It's using sensory details to set the stage. It's got a character. It's describing the characters. It's writing dialogue between them that doesn't seem totally like banal and boring and useless. Now, is it the best short story ever written? Probably not, but it is capable of doing things that are patterned after decent, tropes, or maybe not tropes, abstractions. Complex problem solving. So they prompt it with, solve a complex physics problem such as calculating the trajectory of an object under the influence of gravity and air resistance. The response should include relevant formulas, diagrams, and a step-by-step explanation of the solution. Quick aside, large language models are known to be, quote, bad at math. And that is absolutely true when it comes to performing calculations. That's not what they're modeling, right? They are trained on natural language. Natural language is not what we use to perform math. Therefore, it makes sense that they're not so good at like computing numerical outcomes. They're great at understanding the symbolic language of math because that's a symbolic language. That is a form of language that has rules and patterns and structures that can be learned and picked up and employed. And here it does that, right? It breaks down this really complex thing. I don't know shit about this physics problem, but it breaks it down into steps that seem reasonable, that are part of doing this kind of work, right? And it lays everything out. Now, is it checkable? Absolutely, you would need to check this. But the fact is, it's doing it pretty damn good. So this is the part where we grit our teeth and say, uh-oh, right? Now there's me. I'm the developer of Cognate, a tool associated with this course. And one of my mottos for the tool is, this bot helped me write this bot. So here's me coming in with a programming question. Hey, I'm working on a Vue 3 AI chat app, and my next goal is to add a file attachment drawer. I want to learn it from scratch before I use other tools, as in like before I just find a component from some library and just plop it into my stuff, just because I want to understand it. So can you sketch me how we'd approach this from scratch? Include lots of comments for guidance in the code itself, and explain what we're doing every step of the way. Treat me like an experienced web developer, but one that has never done this specific task before. Hey there, so here we go. Diving into file drawer sounds good. Let's sketch out a plan and I'll walk you through the steps with comments and guidance. Given your experience, I'll keep it detailed, but expect you to vibe with the basics. I gave it a little personality there. So it breaks it down into steps. There's like the super basic one, which is like set up the template. And then now it's saying, let's scaffold the structure of the UI side. Like, what's this component going to look like? And it explains, what are we doing here? Well, we're putting some behavior in the change field. We're putting, what does multiple mean? What is the VIF doing, right? And then it talks about scripting the logic. So it talks about what are each variable we're going to deal with. Files to store, handle file select, blah, blah, blah. Styling, right? And then beyond the basics, it says, we're going to set up basic functionality, and here are some ideas on where to go next. Or we have set up basic functionality. Here's where we can go next. And then I have mine that tends to write haikus at the end, summarizing what we just did. Select files, upload dreams. View brings to life what once seemed a digital stream. A digital stream. Yeah, I did it. So that's step one. This is my first question to it. And I say, great, yeah, let's work on all of those. Keep them in a to-do list at the top, and then in a code fence, and then let's start on the first, a preview for image files. Explain the approach before we write any code, and then we'll do the same thing we just did with you sort of explaining the code, right? And give me good guidance throughout. And so it does, right? It jumps right in, it writes the to-do list, it starts implementing it says, here's how we're going to do this. Here's why we're going to do this. Here's like the explanation of what we are up to, right? It's basically writing a little chunk of a textbook for my specific question, my specific problem. It's helping me understand every step of the way by scaffolding. It updates the component. We talk about the UI and updating that, and then we do some more styling, and we do the basic, that's a single pass of the component. And now, at the end of this, it seems that we have found out what this structure should be. I didn't do this part yet. This was me talking to it to get a demonstration of what I want to do next with the tool. But now is a chance. So if I'm like, hey, I didn't understand some of that, let's talk about it. You can just go from here, right? This is the power of the conversation as the base unit. So I'm impressed with this thing. It helps me build itself. And it helps with all kinds of other learning I need to get done on a daily basis. So maybe an interesting question here is, okay, maybe you're starting to see that GPT-4 is doing this. The next question is, why does this work? If you're curious. It doesn't understand anything, does it? My school told me it's just a plagiarism machine. Why is it able to do this? And my another kind of a cheeky question is, what exactly are we using to define the concept of understanding, right? What would it take for you to accept that I, another human, have understood something that you said, right? And I think if you follow that line of logic, you pretty quickly get to a place where you recognize if you say enough things that show me that you consistently respond with insights that are meaningful, well, I guess maybe you understand. The reason I bring this up is a lot of people get very persnickety about the definitions of things like understanding in a philosophical sense. And I'm a cognitive scientist. I have learned my share of philosophy. I just don't really find it an interesting question. So, hand waving it away. Second, though, is that the real answer here is that we are getting into generative AI. And what that means is that we're going beyond regurgitating the source patterns that it saw, like the literal just flat text that it saw in training, because it's been able to master more complex patterns at higher levels of abstraction that come from looking at a lot of natural language, right? It's like it's unlocking all the little secrets because of its size. So that allows it to use more complex abstractions to generate new ideas, new combinations of thoughts. It can apply some major high-level abstract principle to something new and be kind of in the right ballpark, right? And create something new. So getting at the why still is, the key is not the model itself, right? But primarily the size of the model has allowed it to capture more of this incredible depth and nuance and that come out of the thing that it is modeling, which is natural language itself. So, what's going on with natural language? Natural language is patterns on patterns on patterns. So, let's look at some other realms real quick. In math, you master the rules of algebra, solve any algebra problem. Pretty good. Programming languages. Master the fundamental concepts of programming. You can create, or in another sense, solve the puzzle of any program to do basically anything, at least in the digital space, right? So the common thread here is that if you understand the rules, the patterns of the thing that you are learning, the thing that you are adapting into your system, that's tantamount to learning how to build answers or solutions using those rules, right? Now, let's look at natural language itself. This is the information representation and transmission system that our primate brains evolutionarily stumbled into. We stumbled into a case where we are able to apply arbitrary labels and wield information and store it for later and write it down in words. That's where we have gone in the information era. But natural language is our first and primary mode, right? So it's this universal interface by which we communicate, collaborate, interact with each other across the board, right? And the key thing here is that the more complex these large language models are in terms of their size and scale, the more of the nuance of natural language itself it can absorb, and the more of the high-level abstractions it's able to pick up, right? So it can then wield those rules to work on any problem that can be defined in natural language, which is most problems. So a list of patterns here, things that you see in natural language at sort of the base level. What are the patterns of natural language? Syntax and grammar, the way that words modify each other, right? And must appear in certain structures to make sense. Semantic relationships, the way that words are related to one another, like dog and wolf versus dog and banana, right? They are different levels of related. Metaphor and analogy, so like relationships between things. Pragmatics, like basic understanding that you can't drop a ball in midair and have it float. It will fall due to gravity. Emotion, tone, idioms, references, all these things that are a little bit beyond the raw text and into something a level up from the raw text. You can keep moving up from there. You get into logic, perspective taking. This is sort of the realm of human cognition. Counterfactual thinking, conceptual blending, like we just saw in the Brockman video. Common sense reasoning, that's similar to pragmatics. Symbolic, ethical reasoning, all these things that are built on the abstractions of language at the base level, the abstractions of language and knowledge and information, right? So, the models don't capture every single one of these things, but what happens at a quadrillion neurons or a quintillion, right? Big question mark. Here's a quick demo too, I think is worthwhile. Metaphor as a pattern. It's important to sort of grasp what we're talking about because I think this explains how things scale up. She is the wind beneath my wings. This implies the relationship or the existence of entity she and an entity me. And then there's also a relationship between the entity wind and the entity wings or my wings. The relationship between me and she and me is being communicated by the relationship between wind and wings, which is something along the lines of uplifting, right? So we have a relationship between two entities and a relationship between two other entities being used to sort of impart new insights between them, right? That is an abstract structure. There is the entities themselves, there's the relations between the entities, and there is the relationships between those entities. That is a repeatable pattern. This should be object one, but who cares? Subject one, object one, subject two, object two, inferred relation. That is a learnable pattern, even though it's pretty abstract, right? We're going from entities to relationships to meta relationships. If I can learn that pattern, if I fill in only part of this, it could generate a metaphor. Or if I fill in this, it could find the right metaphor. Or I could say what's a metaphor for uplifting that would be useful. Every one of these, it becomes it will take more knowledge to pick this pattern up and more complexity. But that's where we're at, right? These are the kinds of patterns it's able to absorb the bigger it gets. Now you can abstract that up into even more complex things like reasoning or the pattern decomposition or whatever. So, GPT-4. It's the new big best model on the block. It comes out of the gate with this huge depth of comprehension due to its size and scope, and it shows this never before seen extensive set of capabilities for comprehending language and the information behind the language. So, and the key is the scale. Its huge number of simulated neurons has enabled it to capture more of the complexity and nuances of natural language itself, right? Which we've just gone into depth showing like that's where this is coming from. Natural language is the complex medium through which we do most stuff in the world, and it's able to capture a lot of that. All of it? No, of course not. A lot of it. Enough to be surprising, enough to be useful. So that's where we're at with GPT-4, the Titan. Now let's talk about the barn and how the doors have been blown off of it. Meta's Llama research model is leaked online. So, what is Llama? Llama, so Meta, Facebook, was working on its own set of transformers, large language model Meta AI, and of course they were, right? They weren't really in the commercial market yet with it. They didn't beat the trend to the front. So they just kept working on it internally. And what they started to do was they said, okay, we're going to build 4 different sizes of the Llama model, similar to GPT did, but just in a smaller scale. So they have a 7 billion, 13 billion, 30 billion, and 70 billion parameter model, neuron model. And these are all different sizes, and they're designed such that they can actually be run on a local computer. You don't need a Skynet to run them, right? A cloud server system to run them. And the key thing here is, too, that these are researcher focused. These are developed so that academic research teams could apply for access and study them to better understand them. And you might ask, why study them? Why are we researching them? Aren't they just big tools? Like, yes, of course. But they tend to be kind of a black box, large language models. A lot of AI models, almost all AI models. The trick is, we feed tons of data into them, they learn from it, and then they exhibit these really interesting behaviors, right? But we don't always understand how or why those capabilities emerge. And even though the neurons of these models are simple, or even simpler than human neurons, it's still sort of an intractable problem to just say, well, we took a photo of its behavior and now we understand neuroscience. Like, not really, right? So a lot of research questions come about. Why are they so flexible? What are the differences between the different scales? What properties emerge at different times? What properties do the big ones even possess? That's still a very untapped market. So why we're researching, this is the point. Unfortunately, it leaked online almost instantly. So as soon as researchers got hold of this, one of the hundreds or whatever who had access posted some stupid screenshot of their code base on 4chan, of all places, and turned out or maybe it wasn't directly on 4chan, but then it leaked on 4chan when there was a magnet torrent link that was left visible in the code, which allowed people everywhere to download it. So from here, the internet does what the internet does, which is, here's the meta and researchers copies. It went everywhere, right? Meta's powerful AI language model has leaked online. What happens now? This was a pretty messy situation back in March, right about the same time as GPT-4 is starting to release. Because, whoopsie, these powerful tools that no one's really sure what they can do yet are getting out there to the public. Ooh. Now, this excites me because I kind of think that there's safety and transparency, but we'll see where this goes. Llama escaped immediately, right? So because the data is infinitely replicable and these models are just big blocks of data, they spread out across the whole world. And hacking and open source communities start immediately reverse engineering them to get them runnable. You can run them. At the start it was hard. Now it's kind of easy. I'll give you a link real quick. You can run them. They're not always well. Macs work really well for whatever reason. They have a pooled memory system that works better for graphics computing, parallel computing. But anyway, hundreds of variants. So now Llama is evolving rapidly all over the internet, right, all at once. The real key here is that they can run locally, right? Which means I don't have to pay OpenAI and trust OpenAI to run a large language model on my behalf. I don't have to trust them with my data. I don't have to trust them with like my processing. I don't have to pay them whatever they're asking. I can just do this based on compute. Now, are these things better than GPT-4? Not even remotely close, right? But they're evolving quickly. And there's a big question about, well, how big do they need to be as clever and interesting and useful as the big models? We're going to find out slowly. So they can be run privately by anyone. If your company doesn't want to send its data to OpenAI, local language models. If you want to run the simpler tools yourself without paying corporate entities for them, local language models, right? There's freedom, there's transparency, there's collaboration, there's privacy, right? So the local models emerging at the same time just sets the world on fire together with OpenAI's thing. I want to point out two websites that are useful for this because I don't want to spend the rest of the day on this. HuggingFace.co is sort of the GitHub of open source and freely available, not open source, but available local models. And it's just an interesting place to check things out, check their blog out every now and then. Not a bad place to look for current happenings in the AI community. And then LM Studio. This is I would say it's kind of like an IDE just for conversational AI. It's hooked right into Hugging Face, so you can download models there. You can get the smallest versions of them and give them a shot. And 7 billion parameters, that'll probably run on most people's computers. It just has to fit in RAM, and you got to be patient, but it'll run. Meaning that you can run these things and explore them on your own. No, OpenAI monthly payment involved. Just crack them open and run them. So, the recap on Llama is Llama has escaped into the wild. Meta developed a range of language models at different scales that would be runnable on consumer hardware so that researchers could investigate their nature. Then the internet got a hold of them. So, it sparked this huge proliferation of new models available to run locally, endlessly across the world for people to develop and iterate on. Things are getting wild, y'all. So Hugging Face is the GitHub of free AI, and Elm Studio is a simple IDE for conversational AI that hooks right into Hugging Face, just so that you know. I think that's important to have in your mind going forward in this world, is that these things exist and are available to you even if you're a little behind. So this is the recap. I've given you what I came here to give you. We saw recent history of how AI has shown up in commercial tools up until 2020. In 2020, we see the transformer architecture, well, a little before, but we see it coming to fruition with OpenAI pushing the scale of transformers up to a certain level. And then in 2023, also adding the human interactive element. And in 2023, we have OpenAI releasing this monolith GPT-4 that is the most powerful thing we've ever seen in this capacity. And the world has gotten access to millions of versions of free models in the same space. That's a huge, huge cocktail for the future. So I think the main key insight is that natural language is this deep, rich, complex knowledge representation and transformation system. And the largest LLMs have begun to capture complex knowledge patterns from that system. Also, the interface, which I neglected on this slide, the interface is also itself natural language. Natural language conversations with a well-trained natural language system is a powerful combination. So this leaves us in a place where we, humanity, have started to see what forms of complex knowledge transformation is even possible, and have access to infinite versions of it. Smaller, dumber versions, but things that are going to keep moving and evolving with time. And this is just the beginning, right? Every model we're seeing these days, it's important to remember, this is the worst version of that model that will ever exist. And to pull it back to the text to video side, this is the worst version of Sora that will ever exist. The next version will be way better than this. And that is daunting. So I'll leave you with, in an effort to make sense of this myself a while back, I was conversing with the system and said, what do you make of this? How do you explain this? And GPT-4 suggested, the confetti is out of the cannon when we're talking about how AI has suddenly leapt forward. We know what's possible, and it's available everywhere. The confetti is truly out of the cannon. And I'll leave you with that. Take care.